Good morning. In last video we have discussed the reactivity of alkali metal toward air, that is oxygen, as well as lithium is the only metal that react with nitrogen also and form lithium nitride. Now reactivity toward water. The alkali metal react with water to form hydroxide and hydrogen gas release. So alkali metal, when we put alkali metal in water, then they form metal hydroxide and hydrogen gas will release. And this hydrogen gas, this is called hydration process. It may be noted that although lithium has most negative electrode potential value, its reaction with water is less vigorous than sodium, which has least negative electrode potential value among alkali metal. This behavior of lithium is due to small size and high hydration enthalpy. Other metal of group react explosively with water. They also react with proton donor such as alcohol, ammonia gases and alkynes, gaseous ammonia and alkynes. In this reactivity of alkali metal toward water is what? That alkali metal react with water to form metal hydroxide and give H2 gas. See here metal oxidation will take place. The element which have electrode potential negative, which we have already discussed in 8th chapter, that is redox reaction, oxidation will take place. In this, lithium has more negative electrode potential, but its reactivity still towards water is less as compared to sodium and potassium, which have less negative electrode potential. Why? Because lithium has high melting point, that's why lithium react slowly, but sodium has low melting point, that's why it react vigorously with water and catch fire when you put sodium in water. That's why that's why we store sodium potassium in kerosene oil. Sodium, when we put sodium in water, then it forms sodium hydroxide and H2 gas, and large amount of energy is released because this reaction is exothermic. That's why hydrogen gas catch fire and it start burning, and that's why sodium metal catch fire. This, but in case of lithium, due to their high melting point, they react slowly with water. That's why their reactivity toward water is less, but electrode potential is high. Next, they also react with alcohol, gaseous ammonia and alkynes, and they form sodium alkoxide and sodium soda amide and sodium salt of alkynes. So this is the reactivity toward water, and it is very clear that when we dissolve alkali metal in water, the solution is basic in nature. Basic character depends upon number of OH ion released in water. That in case of alkali metal, MOH bond is formed. When we move up to downward, then the size of alkali metal increase. That's why strength of bond will decrease, and due to this decrease in the strength of bond, that's why their basic character will increase. So basic character of alkali metal hydroxide increase as we move down the group. This is due to decrease of bond length, or this is due to decrease of bond length. So they easily break down and give OH ion. Now next is reactivity of alkali metal toward hydrogen. Alkali metal react with hydrogen and form metal hydride at 673 Kelvin, but lithium react at 1073 Kelvin, 1073 Kelvin to form hydride. All these alkali metal hydrides are ionic, they have high melting point. This is the reaction metal with hydrogen and give metal hydride. See here, when hydrogen is present along with alkali metal, then hydrogen carry always negative charge and metal carry always positive charge, and the bond remain is ionic in nature. So alkali metal when react with hydrogen, they form metal hydride in which the bond is ionic and metal carry positive charge and hydrogen carry negative charge. Due to their ionic character, they have high melting and boiling point. Next is the reactivity toward halogens. Alkali metals readily react with halogens to form ionic halides, that is MX, where M is alkali metal and X is halogen. Lithium halides are somewhat covalent. Why lithium halides are somewhat covalent? Due to their small size, high ionization energy. This is because of high polarization capability of lithium ion. The distortion of electron cloud of anion by cation is called polarization. The lithium ion is very small in size and have high tendency to distort electron cloud, the negative halide ion. Since the anion with large size can easily distorted among halides, lithium iodide is most covalent in nature. Now, this is your reactivity toward halogen. Now, we are going to explain this reactivity toward halogen completely. So, what is polarization? First, write down in your notebook what is polarization. It is the tendency of cation to disturb the electron cloud of anion. This is called polarization. Now write down next line. Greater the polarization, greater will be the covalent character. Now write down polarization depends upon two factors. One is smaller the size of cation, greater will be the tendency of cation to disturb electron cloud of anion. So, smaller the size of cation, greater will be its polarizing power. Next factor is bigger the size of anion, greater will be its tendency to get disturb its electron cloud, because when size of anion is big, then hold of nucleus on outermost shell electron decreases. That's why electron cloud of anion get disturbed very easily. So when size of cation is smaller, then polarization is high. When size of anion is larger, then polarization is high. When polarization is high, then covalent character is high. So lithium is covalent in nature due to its high polarizing power, due to its high polarization because of small size of cation. And in case of halogens, we have four halogens: fluorine, chlorine, bromine and iodine. Bigger the size of anion, greater will be the polarization. So greater will be the covalent character. That's why lithium iodide, where lithium size is smaller and iodide halogen size is bigger, here covalent character is maximum. That's why it is covalent in nature. Reducing nature. Next property, I hope it is clear to all of you. Next is reducing nature. Alkali metals are strong reducing agent. What are reducing agent? Which undergo its self oxidation and cause the reduction of other. Whose undergo oxidation itself? Which have low ionization energy. So alkali metals are strong reducing agent, lithium being the most and sodium the least power. The standard electrode potential which measure the reducing power represent the overall change. The reducing power depends upon electrode potential. In solution, reducing power depends upon electrode potential, and electrode potential is the sum of these three factors, that is sublimation energy, ionization enthalpy, and hydration enthalpy. So in solution, their reducing character depends upon all these factors. So first of all, element undergo sublimation. Sublimation means where metal solid converted into gases. For this process, it absorb energy. That's why sublimation energy is always absorbed. Then gases undergo oxidation and release electron. That is called ionization. This is in this process also energy is absorbed. Then gaseous ion combine with required number of water molecule and form hydrated ion. In this process energy is released. When we sum the sublimation enthalpy, ionization enthalpy, and hydration enthalpy, if its sum is smaller, if its sum is negative, then electrode potential value is negative. In case of lithium, due to smallest size of lithium ion, its hydration energy is more. That's why its electrode potential is more and more negative, and that's why it acts as a strong reducing agent. So it undergo oxidation easily due to its high electrode potential, highly negative electrode potential. And this electrode potential negative value is due to its high hydration enthalpy, because when its hydration take place, then large amount of energy is released. So this is the reducing nature of this one. Now next is the see this problem 10.2. Electrode potential for chlorine is 1.36. Iodine is reduction, that is reduction potential, because here chlorine electrode potential is 0. When it is converted into Cl negative, its reduction, its value become negative, or its oxidation number decreases from 0 to -1, so its reduction will take place. Here reduction potential of iodine is 0.53. Reduction potential of silver is this one. Sodium is to -2.71. Lithium is -3.04. Arrange the following ionic species in decreasing order of reducing strength. Reducing strength means डिक्रीजिंग ऑर्डर. सबसे पहले आपको क्या लिखना है, जिसका रिड्यूसिंग पावर सबसे ज़्यादा है, और सबसे लास्ट में क्या आएगा, जिसकी रिड्यूसिंग पावर सबसे कम है. रिड्यूसिंग पावर सबसे ज़्यादा किसकी होगी, जिसका रिडक्शन पोटेंशियल सबसे ज़्यादा नेगेटिव होगा. सो फर्स्ट लिथियम, देन सोडियम, देन आयोडाइड, देन सिल्वर, देन क्लोरीन. नेक्स्ट इज सॉल्यूशन इन अमोनिया. See here that alkali metal when dissolved in liquid ammonia give deep blue color, which are conducting in nature. Listen why we get deep blue color and why this solution is good conductor of electricity. We represent here metal as capital M, X plus Y ammonia. They represent the moles of ammonia, that is X plus Y. Out of X and Y, we first of all write down metal in ionized form. First metal lose one electron, so it converted into metal ion and electron. Then write down X mole of ammonia with metal ion and Y mole of ammonia with electron. The deep blue color is due to presence of ammoniated electron. These electrons are called ammoniated electron. The color is due to because these ammoniated electron absorb energy and they undergo in excited state. Again, excited state is unstable and they come back to ground state and release energy, and the energy comes in the form of radiation, and these radiation have particular wavelength and give particular color. So this is the reason for blue color of ammoniated solution, due to presence of ammoniated electrons. And due to presence of unpaired electron, that solution is paramagnetic in nature. But when we increase its concentration high, then its color change from blue to brown color. Why its color change from blue to brown? Because uh, these metal ion comes close and they form cluster. And second, their solution becomes diamagnetic. Why it becomes diamagnetic? Because these unpaired electrons, they get paired, because they combine and they get paired. That's why this unpaired electron, when get paired, they show diamagnetic nature. I hope it is clear to all of you all these properties of alkali metal. Please write down all these properties of alkali metal in your notebook. First listen my video, then read it from book line to line, and then make your own notes in your notebook. If you feel any problem, please come and call me. Thank you. Have a nice day.